Hello everyone, I am Soumyshree Senapati, Assistant Professor of Civil Engineering of Vedang Institute of Technology. Now I am going to teach you about elastic constants and relationship between them. Okay. Before starting, we have to know what are the elastic constants. First, Poisson's ratio, denotation is mu. Young's modulus, also Young's modulus is called as elastic modulus or capital E. Bulk modulus, this is denoted by K, and last modulus of rigidity or modulus of rigidity is also called as shear modulus. It is denoted by G, C or N. Okay. Now, what is Poisson's ratio? Poisson's ratio is the ratio of lateral strain divided by longitudinal strain. Okay. Or the ratio of lateral strain to longitudinal strain. Also we can write transverse strain to axial strain. Okay. Now the question is, what is lateral strain and what is longitudinal strain? To define lateral strain and longitudinal strain, we have to know about this prismatic bar. Okay. Now, by taking one prismatic bar, okay, prismatic bar is that in which the size always is same. Okay. In every position the size is same. Okay. Let the size is L. When one tensile force is applied in it, so its after applying tensile force, its length will change. Okay. When length will change, its diameter will decrease. It will increase one side and decrease another side. Okay. So, longitudinal strain is equal to change in length divided by total length, and here the diameter is d. Okay. So, the change in diameter is del d. By that, lateral strain will be del d by d. Okay. Next is our Young's modulus. Okay. Before starting Young's modulus, we know that Poisson's ratio and Young's modulus, Poisson's ratio and Young's modulus are okay. These two are independent, these two called as independent elastic modulus. Why? Why we called it as independent elastic modulus? Because to calculate E and mu, we do not need any other elastic constants. Okay. These two will never depend on another elastic constants. Okay. So, formula for Young's modulus is stress by strain, that is also we can write it as normal stress divided by normal strain. Okay. Normal stress is denoted by sigma, normal strain denoted by small e, Young's modulus denoted by capital E. We have to remember all these terms. Okay. Now, going to modulus of rigidity. Okay. Modulus of rigidity is also called as shear modulus. Modulus of rigidity or shear modulus. Okay. We have shear here. So, we can remember easily that modulus of rigidity modulus of rigidity definition is ratio of shear stress divided by shear strain. We can easily remember this. Okay. So, yes, it is denoted by C, G or N. Shear stress is denoted by tau and shear strain is denoted by what? Phi. Okay. So, G is equal to tau by phi. Next, what we left is bulk modulus. Bulk modulus is denoted by what? K. Bulk modulus definition is the ratio of normal stress to volumetric strain. Volumetric strain is what? Change in volume to original volume. Okay. Normal stress to volumetric strain. We can denote it by K is equal to what? K. Okay. Now, we know all the formulas and definitions of 4 elastic constants. Okay. Now, we have to get the relationship between them. How the relationships calculated are: first we have to calculate the relationship between E and K, that is Young's modulus and what? Relationship between Young's modulus and work modulus. Okay. To find out their relation E and K, first we have to make one diagram. We have to take one square, 3D square. Yes, perfect. Okay, by naming it A, B, C, D, E, F, G and H. To find out their relationship, we need to calculate the total strain. Okay. We have to take these face A and B, this line. Okay. A B line we will take and we will calculate. Here the stress applied will be sigma, length will be L, the stress applied here is tensile in nature. Change in length equal to del L, length will be L, and Poisson's ratio, we know that Poisson's ratio is denoted by mu. What we left? Nothing, this much. From the very beginning, we have to know that here we have taken a square structure. Okay. To calculate the volume of square, so V will be L Q. So, strain on AB will be total strain. Total strain on AB will be what? The first is, we know that tensile force is applied here. So, x, y, z plane are there because it is 3D structure. So, if in x axis it will become positive, then in another two axis it will become negative. Okay. So, strain will be del L by L equals to sigma by E. For which plane? For A, E, H, D and B, F, G, C. Okay. A, E, H, D and B, F, G, C plane के लिए. Okay. Next, for another which plane? A, E, F, B and D, H, G, C. For A, E, F, B and D, A, E, F, B, D, H, G, C, it will become minus of mu into sigma by E. Okay. And for A, B, C, D and E, F, G, H plane, it will become minus of mu into sigma by E. So, we get 3 different values. So, total strain equals to sigma by E minus mu into sigma by E minus mu into sigma by E. So, del L by L equals to सिग्मा बाई ई अगर हम कॉमन ले लेंगे तो 1 माइनस 2 म्यू. दिस विल बी योर इक्वेशन 1. ओके. नेक्स्ट वी नो दैट V equals to L Q. Okay. V is your volume of the structure. So, now differentiating both this side, both sides with respect to L. It will become dV by dL equals to d by dL of L cube. dV by dL will get constant, d by dL of L cube will be 3L square. Now, this dl we will change to this side, 3L square into dl. Okay. This is your equation 2. Now, dividing equation 2 on both sides, dV by V equals to 3L square into dl by L cube. L square and cube cancel. dV by V equals to 3 into dl by L. Before we have got that here del L by L equals to sigma by E in equation 1. Okay. Now, by putting the value of equation 1, we will get dV by V equals to 3 into sigma by E into 1 minus 2 mu. Okay. So, dV by V by sigma will become E by 3 into 1 minus 2 mu. Okay. dV by V by sigma. Okay. Erase it. It will become 3 into 1 minus 2 mu divided by how much? E. So, by dividing both sides with 1, we will get sigma by del Y by V equals to E by 3 into 1 minus 2 mu. Okay. So, from that equation we will get K equals to, before we know that K equals to sigma by dV by V. Okay. So, that will become K and K will become E by 3 into 1 minus 2 mu, or we can say E equals to 3k 1 minus 2 mu. Okay. These equations are important. Okay. So, now we have to go to the another relationship. Now, relationship between modulus of elasticity and modulus of rigidity or shear modulus. Okay. So, okay. Here by taking a square structure, now we have to fix this end, okay, naming it A, B, C and D. We will apply one shear force here, that is equal to tau. Okay. This will change this side. So, when tau will applied here, this will slide down. So, this will this D will change to D1 and C will change to C1. Okay. After applying one shear force, the structure will be changed. So, here we can see this diagonal BD dash is greater, will become greater than BD. But this AC dash is less than AC. Why? Because in case of BD dash, tensile force is acting here. Okay. Tensile strain is here and this is compressed. We know that one side, if one side is increased, so another will decrease automatically. So, total strain in case of BD dash will become how much? Tau by E into 1 plus mu. Okay. But we know that BD is equal to half of shear strain. Okay. So, we know that G is equal to tau upon phi. Here phi is shear strain and tau is shear stress. So, shear strain will become tau upon G. BD will become BD equals to half of tau by G. Yes, we get here BD equals to tau by E into 1 plus mu and here half of tau into G. Okay. Now, okay, by equating those two values, we will get tau upon E into 1 plus mu equals to half of tau upon G. Okay. So, we will cancel these two taus. 1 by E equals to 1 plus mu equals to 1 by 2 into 1 by G. Now, by equalizing those two, we will get 1 by E into 1 plus mu equal to 1 by 2 G. G will become E upon 2 into 1 plus mu, okay. Or we can write E equals to G by equals to 2G 1 plus mu, okay. Till now we have found the relationship between Eg and E and K, okay. Now we will find out the relationship between both those three elastic constants, okay. Between E, G and K. From where? From this, okay. This is your equation number 1 and here this will be your equation number 2. Okay. E equals to 3K 1 minus 2 mu. Another one is E equals to 2G into 1 plus mu. By solving this equation, E upon 3K will become 1 minus 2 mu. E upon 3K minus 1 equals to minus 2 mu. Two mu will become 1 minus E by 3K. Mu value will become 1 by 2 minus E by 6K. Okay. Here we found out the mu value. This mu value we will put here. 2G 1 plus half minus E by 6K. By solving this equation, E will become 2G plus G minus 2GE by 6K. Okay. E equals to 9 kg minus GE upon 3K E equals to minus GE. KE plus GE E will become 9 kg upon 3K plus G. Okay. Here we get relationship between E, K and G. Okay. So, what relationships we get are E equals to two G into 1 plus mu. Another one is here 3K into 1 minus 2 mu 9 kg upon 3K plus G. Okay. These three equations we get. By this solving these three equations, we can get mu equals to 3K minus 2G upon 6K plus 2G, but the derivation is not necessary. Okay. These are the 4 elastic constant relationship we get from those derivations. Okay. Thank you.